Hello, I'm going to explain the stations modules today that includes route, distance, sequence, and transporters. So what are the stations? The stations are used when, for example, a manufacturing facility consists of several departments. So we are going to use stations for these different departments. Each department has its own components, operates according to the certain sequences. So, for example, sequence of different stations together. In order to simplify these models and to present the material or information flow more visible, instead of creating one large physical connected organization, we can use several stations working together can be generated in ARENA. So station is a block, part of the discrete processing group when a number of physically different locations are modeled, use station, and it can maybe useful. Examples is like, for example, entrance station, storage room, workstation, milling room, painting room. The advantages of stations are that it can help to group similar processes under the same name. It allows to use transporters. When transferring items from one place to the other, distance between them may be required to include in the model. For example, 10 meters, 20 meters from station 1 to station 2. Use of the stations enable to include and use these distances. Modeling of complex problems become relatively easy by station. The next block or module that we can use is route. Each entity might follow different sequences in the facility. Sequences of entities can be set in ARENA using the route or routes block. It is part of the discrete processing group and is used to send the entities to desired paths. So when used with the stations and sequence element, one can route the objects to a number of different places without using logical operators. So it can provide the sequences that the part should go. Let's put it in an example. Here we are going to model this question. We have three different parts, part A, part B, and part C. 30% of all parts are part A, 50% are part B, and 20% of the parts are part C. The sequences that part A follows is, it starts from the entrance, then milling, painting, and exit. B starts from entrance, and then milling, drilling, painting, and exit. And C has this sequence from the entrance, then drilling, painting, milling, again painting, and then exit. So we see that we have different sequences of stations for different types of the entities or types of the part. Here we have the departments or stations and the processing time for each station. Time between arrivals is expo of 1 per hour here in this example. And we have the distances as well. For example, the distance between the entrance and other stations, the milling, the drilling, and painting. The exit is already considered in this matrix. So this is our question, and we want to model it. If we don't use stations, first of all, we have to always check which entity type it is. So what is its next step? If it is, for example, part A, after milling, it should go to painting. If it is B, after milling, it should go to drilling. So always we should check. Also, if we want to consider the distances, we are not able to do that. So we are going to use stations and model this example. If I'm going to use stations, I'm going to create entrance and exit and milling, drilling, and painting stations. Here I will create arrivals with use of create module. Then I will consider what is the type of the order, 1, 2, or 3, which means part type A, B, or C. Then I will go through the entrance station, and with the route, I will go through the next route, the next station based on the type of the part, which can be any of the stations based on the sequence that I will identify. But the general model is like I have the entrance, milling station, and milling process, then go to the next station. I have drilling and drilling process. I have painting and painting process. I have exit and dispose. So this is my model. I'm going to explain this model in the arena and how each part is created. So in the create, I have the random expo with value of 1 hour. Then in the assign module, I have identified the types of the products with the attribute named order type, discrete, 0.3 means 30%, part 1 or part A, accumulative, 0.8 means that 50% part 2, accumulative 1 means that 1 minus 80, which is 20% for part 3. So I assign parts 1, 2, and 3 based on the discrete. I will explain the entity sequences later. Now I created my entrance station. So as you see, a station is derived from my discrete processing. I have found a station. I bring it here. In this station, I simply name it. For example, station of entrance. Type is a station, and this is the station name. That's all that is important about the station block or station module. So here you see that I called it the name entrance, and the station name is entrance station. They can have closed names. Then I have the route. This route is coming out of the entrance, so I called it the entrance route. I didn't consider any route time. I could say, for example, for this route, it takes some time. And destination type is important in a route. If I use station for the destination type, it means that I should say what is this next station. But I don't know what is my next station because it depends on which type of the part I have. Maybe it is part 1 and immediately after entrance it will go to milling, or not. It will go to drilling. So instead of a station, I will use by sequence. When I added by sequence, so of course I have to identify my sequence somewhere. Where I'm going to identify my sequence, if I go to data definition, sequence, I will create 3 sequences, 1, 2, and 3 for 3 different product types or part types that I have. Sequence 1, open it and create 4 steps for that. So if I have a new sequence, in this part, I will create one by one the sequences. For example, I will choose entrance and I will choose the next step for that. As you can see here, I would choose the entrance, and if I need to assign the, for example, the process time here, I can do that. But for me, it's okay. Just I want to consider it the entrance. If I want to have a name for these steps, I would. But for me, it's enough to say that this is my entrance station. Then I have my next station, which is the milling. Then it is painting and exit. So I can here assign the list of the steps for this part. For part 2, I had this sequence that is starting from the entrance, milling, drilling, painting, and exit. And for the third part, I had these sequences: entrance, drilling, painting, milling, again painting, and exit. So as you see, I have assigned 3 sequences for 3 parts. Part 1, 2, 3, 3 sequences. I will delete this extra one. So pay attention. I'm going to now assign these sequences to my part. So that's why I'm careful to start with sequence 1 related to part type 1. Now that I created my sequences and I know that my route is by sequence, come back here in this assign, I would say assign an attribute that is entity.sequence. Entity.sequence is predefined attribute from Arena. So you open this and you will see it. I mean, if it is a new assign, it is attribute. Open this list and you will see like entity.picture, entity.sequence, entity.station. So you see that entity.sequence is something from Arena that exists for each entity. So I will say entity.sequence is order type. What does it mean? It means that order type 1, entity sequence 1, order type 2, sequence 2, and order type 3, sequence 3. The most important part of this sequence is to assign sequences to the order types. If we do that, then the sequence will be automatically assigned to the routes. Now, after the entrance route, I will go through the milling. I will physically put it here, but we know that based on the sequence, the parts will follow. Milling process, it is mentioned that the time of this process is normal with the average of 2 and standard deviation of 0.5, and I have the resource. I add a resource. I name it milling resource. Then I have to use the route again by sequence. Drilling, the same thing. Drilling process. It is mentioned that it's triangular, and it is the resource that I will add as drilling resource. Then I have the drill route. Then I have pinning. I have pinning process and the route for that. And finally, I have the exit and disposal. So I actually finished my model by adding sequences and stations. One thing that I want to also show here is the distances. We have a material handling group that here we can find the distance. I can add a distance And then I can provide the distances that are already mentioned. For example, from the beginning stations of entrance to ending of milling, the distance is 10. The entrance to drilling is 10. The entrance to painting is 20. For now, the use of this is not applied, but if I use a transporter will consider this distances as well. So coming back, to summarize our model, we will create the sequences in the data definition sequence. For example, sequence 1, station 1, 2, 3, or station 1, 2, 5. In the model, we will add the type of the parts. We will create the stations and route, and we will create the sequences and assign the sequences by using entity.sequence value order type. We can assign the distances. So here, my model is created by using the station and sequences. Now, when I run this model, for example, I run this model for 120 hours, I see that the total output is 58. So simply based on this pictures, I can see that in the milling process, I have a huge weighting. So you see I have 70 work in process here, but here I have only 2. So if I add the number of the milling machine or milling resource, it could be helpful to improve my flow. As you see, I added it to 2 and I had the output of 106. However, here I had the output of 58. So that would be helpful for improving my material flow. Another object or another concept that I can use with the station is to using transporters. For the transporters, for example, consider if you are using a forklift or some other vehicles, or even the specific operators for moving these parts between the stations, or if you are using the conveyors. These are kind of transporters. So if I am going to use this individual transporters or conveyors, which modules or blocks in Arena I should use? So the task of this individual transporter is to request a transporter, load the transporter with the parts, products, and then perform this transportation and free it. It's like considering seize, delay, release. Here we have the request, then we have the transport, and then freeing that transporter. So these 3 modules can be helpful for using a transporter. I will request first. So I will request a transporter. For the selection rule, I can use some rules like smallest distance, cyclical, random, preferred order, larger distance, or specific member. These are some rules that we can use for applying a transporter. Then we have the entity location. That is important, that our entity location usually is very simply to be entity.station. It is also a default attribute in Arena that will simply find the location of your entity, and then you can simply find it and apply transporter. So this is my request module. The important parts are to use a transporter, use some rules for applying it in the entity location, the best use is entity.station. So the station will be fine. So in this request, Arena calculates the travel time from the transporter's present station to the station of the requesting entity and impose a time delay representing the travel time using velocity. So here I had a part that is called velocity. Also, it is good to consider the velocity. So if I have a velocity for my transporter, and I already have the distance that I calculated, so the time that it takes for this transport or this transfer will be calculated. Let's look at an example. Rather than specifying a time to transfer, we will specify a velocity and a distance for the transfer. From the velocity and distance associated with the transfer, the time of the transfer can be computed. For example, if distance was 10 units and velocity is 5, so it means that my travel time would be 10 over 5 or 2 minutes. So with the velocity and the distance, I can consider how long it takes to do this transfer. So if I completed my request, now I have the transport module. Transport module, we identify the destination is which station. That is important. For example, I would say that entity destination type is by sequence. So now again, the sequence will be applied. Velocity, I can use it here again, and I can also make sure that this transporter uses which distance set. It can have the distance that I have already created or might use a new distance that I create for this in this transport. So pay attention that it should be identified. And finally, I should free this transporter like seize, delay, and release. I have to release it. So that's how we can add a transporter. Let's add a transporter in the previous example. So in this example, from milling to drilling, I used a transporter. I assume that I have a transporter, so I requested a transporter. It is named transporter 1 and cyclical entity station velocity of 5, and the Q type is the normal default of Arena. If you look at the material handling, you can look at your transporter here. So I have transporter 1. For example, I have 100 of them. I have one of them. How many I have here? I had lots of requests, so I increased the number of the units. I can say what is the path, what is the distance set, velocity. I can increase the velocity here, use it, for example, 5, or I can add initial position. I would say that I want it to be, for example, from the milling station. And this is all about my transporter. When I request, I'm requesting this transporter, and I will use transport. So transport by sequence. And finally, I will free that transporter. So I can add this in my Arena station module. Request, transport, and free it. is another example. To produce automobile doors, 4 different processes are required. Each process is performed in a different workplace. Doors are transferred between workstations in batches with a batch size of 10. Using a forklift, there are 2 forklifts available. The distances between the workstations and the processing time in each station is given. Simulate the system for 500 hours. So what I have here is I have a list of some stations. I have the distances. I have a transporter that is a forklift and it has a speed. And I have the time between arrivals, 30 minutes exponential. Here there is a new word that is batching. In this case, when we are using a transporter, which is a forklift, we are going to put some of the products together. We are not going to use our transporter only for one product. So we will use a module that is called batch module and simply put products together. And then when they are freeing the transporter, we will again separate this batch. It is a temporary batch. How it works is to starting to create our arrival. We have the first station. We have the batch of some products together according to the information we have. Then we request the transporter transport to the station 2, free that transporter, and also separate this batch and do the first process. So these are all batch request transport for using this transportation. So if you open the batch module, it has a name, it has the temporary, so it's important. We are not going to put these products together forever. We are going to just put them together for the transport, so it's temporary. The batch size is 10, and the save criterion is not important as we are going to just again separate them. It would be more important if I wanted to keep them together as a new unit. To the separate, I would say split the existing batch. So simply, I'm going to splitting this batch and separate the products again. So that's the situation that I will add all of the stations in this case and the distances for this example. So it's an example of using the batches and the transporter. Finally, I have another kind of transporter, which is not individual, and it is conveyor. So the conveyor is a bit different from the transporter, and we use some other modules for that. But this logic is exactly the same. I'm going to use access, convey, and exit. So access to the conveyor, use the conveying, and exit that conveyor. That's how it works for the conveyor. So we have some details about the conveyors. If I use a conveyor module, I should identify if it is accumulating or non-accumulating. If it is accumulating, so this several entities can be on the conveyor at the same time. If it is non-accumulating, parts must keep to have a gap. So if this conveyor stops, every part is also at their own place. They are not going to move and be together. And then I have some details about my conveyor. The velocity. So again, I have the velocity, for example, 20 per hour, like the previous example that I had the velocity. I have the cell size. For example, here is the size of each cell. As you see, what is the meaning of the cell? So I might pay attention to the size of the cell according to the total length of my conveyor. I have the max cells occupied, which is the maximum number of the cells that can be occupied at once on this conveyor. And I can consider accumulation length should be how long, and if I have the initial status, which is active. So I have a conveyor here. As you see, it is in the material handling conveyor. You can see the details here. So in this conveyor, I would consider whether or not it is an accumulating or non-accumulating. Also, it can consist of a sequence of some segments. Here, the segment comes with the conveyor. It's another module that considers the start and end physical place of a conveyor, which is called a segment. So here, if you look at the conveyor coming back here, this is my conveyor module. You see that conveyor one segment. So I have to create also a segment for my conveyor. Let's look at the segment part. Here is my segment, and I would say that it is from, for example, starting location, beginning station is conveyor loading, or the end is the unloading. And the length of this conveyor is 300. So always conveyor comes with a segment. As we talked about the cells, we see that each cell has a size, and the number of the cells are also identified. For example, if I have 15 cells with the size of 1 feet, I have the 15-feet conveyor. So this is the information about my conveyor, and how I use it is with access, convey, and exit. So I will get access to a conveyor, use it, and exit and release it. So here, as you see, I have some information about my access, number of cells, the conveyor type, the conveyor name. I have the conveyor conveying from, for example, which station I'm going to, and exit of this conveyor. So here is the segment. So in this example, I have the create, assign station, access, convey station, and exit, do the process, and dispose. Here I'm going to show you an example. In Arena, which is the conveyor. So it has the conveyor and also the request. So as you see, I have the station of the entrance, then I have the request of a transporter. This transporter will bring me here to the conveyor. And here you see this is my conveyor. So if you look at the transporter information, you have it. If you look at the conveyor segment, you see that I have a conveyor and I have a segment with that. This segment is the one that says my conveyor starts from the conveyor loading station, and this next station is unloading. As you see, starting from this station, which is my entrance or my conveyor loading station, and it will end at the unloading station. So that's the meaning of having a conveyor. And then I will have my request 2 of a transporter, and I will finish my transfer with the transport 2, and then I will go to the station, another station, and free my transporter and leave the system. So if I run this model, you can see how it works for transporter and conveyor. So transporter is an individual vehicle. Conveyor is a conveyor that will be used for the products. So I will provide this information in the Moodle, and please ask in the class if you had any question in this regard.